just create an R script. Okay, and I will share with you one data set, the same data set. This data set you can practice along with me. In case of any problem, you can ask me. Basically, we will use two different package. You can use only one of them. Okay, one is called this one. Okay, and another one is called stats. Okay, so both are freely available. You can download and you can install them in your R environment. Okay, so here I am loading this library psych and then library stats. Okay, I've just loaded it. Okay, now what you have to do, you have to load the data. So data set I have shared with you. Now after loading the required packages, load the required data set. So for this a simple function, that is read table. Okay, read table will be used, and the source. Okay, data is already loaded. Just for your understanding, I have break the line. There is a technique for breaking the line. You can follow that, or you can just copy one by one, type one by one, and then load the data in a data frame. That is called data. So if you require to install them, it was like previously loaded with my R. So I don't know whether it is present in your R library or not. So in that case, you can install it. Hope you have loaded the data in the library into the working environment in R. And if you look at the data set, then you can see the data set is the same, like you have 20 rows and 6 columns, right? Although it does not fulfill the required criteria, but it's a small data set. You can, in real cases, you must follow that criteria of minimum 5:1, and in general it is 10:1, and better it is 20:1. Okay, so in better case there should be 6 multiplied by 20, that means 120 rows should be there. In average case, 10:1, that is 60 rows should be there. And in case of minimum as a minimum requirement, there should be 5:1, that means 30 rows should be there, but instead of 30 we have 20, so we have less than minimum requirement. Okay, so after this, what you can do, what you need to do, you need to do the scree test, right, or generate the correlation matrix, whatever you want. So first, as per the explanation what I have done here, so this is the loading the data, and then I have performed the test, finding out the scree plot or drawing the scree plot, right? For this, plot scree or find factors, right? So for this, what you have to do, you have a function called scree. Okay, there you send the data which you have loaded just now, and then pass some parameters which are factors equals false. Okay, So you for the better understanding, you can go and you can look at the screplot function, and what it will generate? It will generate the eigen data, right? Eigen data. So just wait for it. So eigen data is generated, and now if you look at the eigenvalues, eigen data dollar, there is PCV. So I think I missed one library for the data set, that is mass. So library mass. So if you load it and then again do these steps, yeah. So if you plot this, if you write this code, it will plot this diagram. So see, look at this diagram. Hopefully it is similar to this whatever I have shown you earlier, right? So where you don't have exactly like knee-like structure or kink-like curve. So in that case, what you can do, you can just consider the number of points above the one line, and then here you have three dots. So if you want to check mathematically, then check on this and then see, in this case here, see 1, 2, 3. Three values are more than 1. Three eigenvalues are more than 1 among these 6 factors, right? So we can say that 3 is the usual, 3 is the best, good factor value for this factor analysis, right? So this part is done. Now we have to generate the correlation by matrix. So to do this, what we can do? We can generate the correlation, or we can use the core, the usual core function. We generate the correlation matrix. So find the correlation matrix. Okay. So for this correlation matrix, what you have to do, you have the data in the data variable. So for data, and that will be loaded in some data. Okay, so if you want to see this, then print correlation data, and you can see that this data also says that sociable has the correlation with outgoing, hardworking has the high correlation with dutiful, and warm-hearted has high correlation with helpful. But if you look at the data set, the values are not exactly same. In case of this Cree mass is the library where this plot will come. The required function is present there. For this experiment, I have just loaded these three: library mass, library p size, and then library stats. and till now I have just used stats and mass. If you look at the correlation matrix, it is the same correlation data. A little bit of variance may be there because here you have only 3 decimal place, but here you have 8 decimal place. So variation of very fractional part is there, but you can see the exact correlation data set which I have shown you here. Now after generating this correlation matrix, now going to do the factorial analysis, right? Because now you know the number of factors, because here you have already seen number of factors, and that is 3 by this tree plot, right? So by this number do the factor analysis. So perform the factor analysis. Very simple operations I am doing so that everybody can understand it. And for this factor analysis, for these two packages I have used stats and psych. In case of stat, okay, so stats package, if you are using stats package, you have fact analysis, factanal, okay. So this function you can use it. There you can pass the data and write the number of factors, and the factors you have decided, or you have found out that the number of factors is equal to 3. So write it there, okay, and then you save the output in FA data, factor analysis data, right? So this is for statistical package, and for the psych package, okay, there is also the output. I am giving the same name with extra 1, and there you have a function called FA, fact analysis, okay, and the same data you are passing there, and instead of factors there will be n factors, okay, and the value will be 3. Both way, either this one or you can do this one, okay. Now if you run this piece of code, okay, you will get the all outputs. Now if you just look at this output, see there are many things, okay, the uniqueness, loading and all. So for loading, what you have to do, you have to use the loading part of that result set. So FA data, and just use the loading, okay, and this you store in loading data and print it. Okay, so you can see this data set. This portion is same as next one. Go this one. No, not this one. Factor loading, this one, the component matrix. So this one is nothing but the component matrix, okay. So for better understanding, rename it component data, okay, component data. Now component data 1, FA data 1, and do loadings. Okay, so this is working again. Now you print the data. Sorry, this one, print the data. So see what is the difference by these two packages. You are getting this value and this value, and there you have name factor 1, factor 2, factor 3. Here you have name mr1, mr2, mr3, right? And the variables are of little bit of difference, because the parameter you are using, okay, let me make it little bit less. Yeah, the parameter you are using are different. In that, though that function, the default parameters are different, so that why values are little bit of differences here, you can see. Okay, but in both the cases, where it is high it is high, where it is low it is low. Okay, so like for example, it is showing 0.677, here it is showing 0.7, here it is saying 0.947, here it is showing 0.952, so very little differences are there. Okay, both are okay, both are correct, you can use any one of them. Okay, now so this is this part, the component matrix is generated. Now what you can do, you can generate the communality matrix, right, where you can understand how much variances is actually explained or actually captured by which factors or for which variables. So here find the communality matrix or communality value, right? So for this, what you have, you don't have to run any function, but whatever the output you have received here or you have generated here, that is component data or component data 1, there you have communality, right, and then run it. What happened? So communality data 1, okay, so this will only work for this part. So component data not working. And this will only work for this psych package or psych package. This will not work for stat package. Okay, so only for psych package. So find the communality value, but it is no, I'm not getting it. Okay, I'm getting the wrong one. So it is a FA data, not the component data. So it is FA data 1. Yeah. In FA data, you have communality or communalities. See, you have two functions, two values. So communality or communalities both are same here, but there's a little bit of difference. I will show you all of them, don't worry. Now, so you can generate this part and you can check the values one by one. Although there will be a little bit of differences, outgoing have 0.775 here, outgoing have 0.4731. So based on that different parameters, it is giving you different values. Okay, so after this, what you have to do, you have to do the factor scoring, right? What was the main goal of for us for doing this factor analysis? And before that, if you want to see that which factor is going to which variable, or which variable is going to which factor and which factor is representing which variable, you can plot it. So plot the relationship. Plot the relationship, and for this uh, you have FA data, and then you load